Like many gunsmiths before him, Wallace Gusler begins a rifle at the forge. Here he will heat and hammer a bar of solid wrought iron into a flat scalp, heavy at one end, tapering slightly in both width and thickness to the other. On the swage block, Mr. Gusler prepares to fold the scalp lengthwise. The edges will then be welded together to form the beginning of the barrel.
I judge the heat strictly by eyesight and hearing. You can hear the hissing of the metal when it's at the fusing point. At the right temperature, you also get a lot of white sparks flying from the iron. The purpose of the steel rod, the mandrel, is to keep the bore from collapsing as you hammer. Flux is used for the welding. This is made of borax, iron filings, and sand. The flux melts over the surface of the iron and keeps scale from forming. The iron will not weld through scale. Once the barrel is heated to the fusing point, you only have a few seconds to hammer. The hammer blows need to be fast and moderate in weight. The metal is very hot, and if you hit it too hard, you'll hammer it too thin. By taking the barrel back to the forge quickly, you don't lose much heat. You start welding the barrel in the middle and work toward the ends. It takes many welding heats for each little section to get the iron consolidated at the seam. It will take several hundred welding heats to finish the barrel. Rifle barrels are formed in an octagon. The octagon doesn't have any practical use. It's just style.
The forged tube is just the beginning of a barrel. Mr. Gusler has yet to perform many cutting operations on it. To soften the iron, he heats it to a dull red all over and then buries it in the cinders so it will cool slowly. This is called annealing. The perfect gun barrel is a smooth, straight tube. It should be nicely finished on the outside, have an even wall thickness, and be as polished as possible on the inside. The objective of the boring operation is to produce a straight, smooth hole of the proper size. The boring operation itself is quite simple. The barrel is mounted in a sliding carriage. It is lined up with a chuck and held in place with wooden wedges. Then a long bit is attached to the chuck. The bit is oiled with linseed oil. In operation, the bit is turned by a heavy crank, the weight to provide momentum and smooth the turning, and the barrel is pushed into the bit.
The first boring bit does not cut from end to end. It just hits the high spots in the barrel here and there, so I push this through by hand. Each new bit is a little larger in diameter and longer in cutting surface than the one before. We use about 12 to 15 rough bits. Once we get a bit cutting the whole length of the barrel, we drive it with the chain and weight. Gravity feed is ideal for this type of work because it will slow up at the hard spots. If the barrel advanced at a constant speed, it would break a lot of bits. I don't believe I've ever bored a barrel, though, that I didn't break at least one bit, sometimes two or three. First thing you do to repair a bit is to anneal it. Heat it to a dull red and let it cool off slowly. Then I have to file it down to a taper again and retemper it. When they get real worn, we usually just forge them out and make smaller sizes out of them. When you're taking a heavy cut, you have to clean off the bits every inch or so. The borings are saved and used for flux. Occasionally, the barrel is cleaned and checked for straightness. Bends and crooks can be seen by sighting through it at the window. These can be hammered out on the anvil. All this is gauged by the eye. No straightening device is used. The barrel may be taken out of the machine 3 or 4 times to straighten and inspect for flaws. Flaws are cracks or pits inside the barrel. Like I said, the bits get larger in diameter and have a longer cutting surface. This helps bore out the crooks in the barrel. The longer bit will bore out a small crook that the shorter bit would have followed around.
The slight roughness left by the cutting bits is now removed by the finish boring with a square reamer. With this bit, the square corners do the cutting. A hickory backing piece is used to press the 2 cutting edges against the metal and to make the bit run smoothly without chattering. This bit takes a very light cut and the barrel is pushed by hand. The borings are as fine as face powder. Mr. Gessler needs only 1 size of square reamer. After each cut, he adds a slip of paper under the hickory, and this will deepen the cut slightly. The gradual addition of 8 or 10 more of these paper shims does not appreciably enlarge the bore, but rather burnishes it to a mirror finish. With the inside of the tube finished, the gunsmith and his helper now finish the outside. This is done with that most used of all gunsmithing tools, the file. The object is to remove the rough forging marks, but not to remove so much metal as to weaken the barrel. Filing is a long, tedious job, hence the 3 facets or flat surfaces of the barrel, concealed by the wooden stock, are not finished as smoothly as the 5 that show.
To make sure that the flats are straight, the file is used long ways so any humps can be seen. The muzzle end is filed even so that the hole is centered. We file the flats in pairs opposite each other. First 4, and then the 4 in between. The barrel is widest at the breech and tapered toward the muzzle. The last few inches are flared out, again for appearance. The bore is straight inside. Once the barrel is smooth filed, it is polished with emery. Only the top 5 flats are polished.
While most military arms of the 18th century were smooth-bore muskets, many Americans tended to prefer rifles for their personal arms, especially on the frontier. A rifle is more accurate, though slower to load. An 18th century rifleman could hit his target at 300 yards, while it was said anyone hit at 150 yards by a musket ball was indeed unlucky. Rifling is cutting spiral grooves into the bore of the barrel. When the gun is fired, the rifling gives the ball a spin. This stabilizes the bullet, making it much more accurate than a musket ball.
The rifling grooves are cut with 2 steel teeth set in an iron rod. The rod is pinned to a spiral guide. wooden shim is placed behind the teeth. All the cutting of the rifling is done from the breech to the muzzle. As the teeth are pulled through the barrel, they are turned by the spiral wooden guide, reproducing the same spiral pattern on the inside of the barrel. After each cut, the guide is rotated to its next position. There are 7 grooves on the spiral guide, so there will be 7 grooves in the barrel. After the first 7 grooves are pulled through, the depth of the cutter is increased by gluing a paper shim on the hickory backing. The papers are glued on to keep bits of metal from getting between the paper shim and the backing. Putting on a piece of paper increases the depth of the cut so much that the bit is very hard to pull through the barrel.
Back it up.
Once the first 2 or 3 passes are made, the paper is compressed and is easier to pull through. Altogether, 8 to 10 paper shims are built up and pulled through during the cutting of the grooves.
Six days after he began work at the forge, the gunsmith has almost finished the barrel. One step remains. A bullet cannot yet be fired from it. The gunsmith must close up the back or breech end, and to do this, he forges an iron breech plug. This is sized to fit inside the barrel. He will eventually thread both the barrel and the breech plug to make a firm attachment that allows the plug to be removed when necessary. The long extension is called a tang and will be used to hold the breech end of the barrel in the stock.
In threading the breech of the barrel, I usually cut 6 full threads, which makes the breech plug about a ½ inch long. It's important to have good, strong threads in the breech because the breech plug is the only thing between the shooter and the powder charge. The breech plug itself is threaded with a screw plate. It's forged longer than necessary with a taper to make it easier to start the screw plate. The excess is then sawed off. Since only 5 flats of the barrel are finished, you have to line the tang up with the top flat. The only way you can do this is to file down the breech of the barrel until the plug turns around to the proper flat.
The final step in making the barrel is drilling the touch hole through which the charge is ignited. The barrel is complete and needs only to be proofed or tested. This is done by loading 4 times the normal amount of powder along with a patch and ball. This will then be fired from a safe distance.
In normal use, if you fired that amount of powder in the weapon, there would be such a recoil that it would most likely break the stock. We use an old lock to fire the powder train. The barrel is inspected for cracks and swells. These would mean it's no good. Later on, it will be taken back to the shop, unbreeched, and checked inside.
Once the barrel has passed its test, Mr. Gustler begins work on the lock. This is the mechanism that fires the gun. He starts by forging a piece called the cock. The flintlock uses the same principle as starting a fire with flint and steel. The flint, which is held in the cock, strikes a piece of steel, shearing off white-hot bits of metal. These sparks shower into a pan of gunpowder. The fire flashes through the touch hole and ignites the powder charge in the breech.
At a white-hot temperature, the iron is very malleable. With the right tools, it can be shaped into about any form. Like wood, iron also has grain. But in iron, the grain is forced into the shape of the object as it's forged. So a forged part is much stronger than the same piece cut from a solid bar, where the grain all runs in one direction.
"20 or 30 minutes of forging is followed by 2.5 to 3 hours of filing. The most commonly heard sound in an 18th century gun shop was the sound of filing. Literally every part was filed at some time. The file is a simple and ancient tool, and those from sites 2,500 years old look the same as those made today. In the 16th century, Leonardo da Vinci designed a file-cutting machine. By 1770, the craft of file making was highly developed in Europe with all the trappings of guilds and specialists.
I made the pan borer, which is used to shape the cavity for the priming powder. I cut teeth on it like a file instead of making flutes like a reamer. In fact, I make just about all of my tools, except for files and hacksaw blades. Even things like screw plates or dies are easier to make than the lock of a gun. Once the lock plate and cock are finished, the remainder of the inside parts of the lock can be made in proportion to them.
While Mr. Gustler is forging the internal pieces, his helper is at the merchant store buying supplies. Such things as iron and lead, soft coal and charcoal could be obtained within the colony. So could scrap brass, a necessity, since it was illegal to import unworked brass. Flints and powder were customarily imported at this period, yet it was to the colonists' advantage to use as much locally produced material as possible. By the time of the Revolution, much of the powder needed to fight it was being made in the colonies. Now, the inside parts have to be filed to shape, each part being finished in relation to the other parts. The history of guns up through the 18th century can be told in the development of locks, which replaced the original handheld fuses. Early in the 15th century, mechanically held fuses became a part of the gun and were called matchlocks. The wheel locks solved the problems involved in carrying a burning fuse. This lit the powder with a spark-producing device similar in principle to a modern cigarette lighter. At about the same time, the first complicated flint and steel locks were devised. These were refined and simplified until the beginning of the 17th century, when the present form of flintlock was developed. This had but 4 moving parts and was in use for over 2 centuries, longer than any other system to date. As the size and shape of locks varied widely, the screws were made by hand for each individual purpose. Inside the lock, the tumbler controls the movement of the cock. This is held in place by a piece called the bridle, which also holds the sear. The sear engages with notches cut on the tumbler to control it. The sear, in turn, is controlled by the trigger.
The steel is made of an old file welded to a bar of wrought iron. Welding wrought iron and steel is hard to do because they have different fusing temperatures. The file is the hard striking area for the flint. The wrought iron gives it toughness. If it were made entirely of steel, it would be too brittle and very likely break. Sometimes they are made completely of wrought iron and case hardened. In other cases, a piece of steel is riveted or brazed on the iron. Besides being a striking surface for the flint, this piece is also the pan cover. When it's down, the steel is in position and the powder is protected. When the flint strikes, it knocks the cover open. A spring keeps it from flopping around.
The power to snap the flint against the steel comes from a large leaf spring forged out of imported spring steel. Besides this main spring, Mr. Gussler must also make two similar but smaller springs that hold parts in position.
Springs are a real aggravating part of the gun to make. Forging spring steel has to be done much more carefully than wrought iron. If the steel is overheated, it's ruined. Likewise, if you hammer it too cold, it damages the fibers. The springs are V-shaped, so the inner surfaces are filed and polished before they're bent. Afterward, you can't work on the inner faces. Deep file marks or forging flaws may cause the spring to break, so it's polished. It takes 3 or 4 heats to bend the spring into a V shape. The spring is held in place by a screw at one end and a pin at the back that goes through the lock plate. Decorative bevels are filed on the spring. They have no function at all. A good spring should bend evenly from front to back. After tempering, its action should be smooth and crisp and not feel mushy. Springs are tempered in lead heated to the boiling point. By submerging the springs in the molten lead, you get an even heat throughout the thick and thin parts. After heating, they are quenched in linseed oil. After quenching, the springs are very brittle. They are then polished, put on a bar in the forge, and heated. This softens them somewhat and gives the springs flexibility. As the heat increases, colors appear. The colors are first yellow, then violet, then blue. Pale blue is used in tempering springs. These colors are used in tempering tools also. Engraving chisels, which have to be harder than springs, are quenched when they are yellow. After tempering, the springs are worked gently to break them in. They are not compressed completely all at once. If a spring is too strong, it can be filed down to weaken it. It files with reluctance, but you can file it down.
When the cock is pulled back, the mainspring will be compressed. To hold it there, the gunsmith will cut notches in the tumbler for the sear to catch. The full cock notch is cut square so that the sear can be tripped easily. The half cock notch is undercut so the sear cannot be disengaged. This position is used as a safety. The gunsmith's individuality was often expressed in the engraving. His design was usually scribed directly on the metal and then cut with an engraving chisel kept lubricated by linseed oil.
The basic building blocks of an engraved design are C scrolls, S scrolls, flowers, leaves, and shell designs. The combination of these different details can create endless variations. Or if you took the same design, you might be able to engrave it 500 different ways. You have these various options. You can make some parts move toward you and some move away. If all the pattern is cut the same, it's flat. If you vary the depth of the cuts, it has much more feel. You get a three-dimensional effect.
Finally, the lock is ready for case hardening, which will improve the strength and wear resistance of the lock. A crucible is filled with a mixture of powdered charcoal, ground charred bone, and charred leather. The lock is disassembled and the pieces buried in the crucible. Sealed from the air and surrounded by this mixture, they'll be heated red hot in the forge. The surface of the iron will absorb carbon and thus be converted to steel, while the body itself retains the resiliency of wrought iron. After 5 or 6 hours of heating, the surface steel is hardened by quenching in water. The finished lock is put together and tested for spark. Apart from the barrel and lock, a gun stock requires other metal attachments called mountings. American rifles of the 18th century commonly had brass mountings. Some of these were cast in sand molds.
The first sand is called facing sand, which is a very fine sand mixed with powdered charcoal. This is only used over the patterns. The fill sand is much coarser. Both sands are bound with water. This forms the bottom half of the mold. Once the bottom half is packed, it's turned over and the matchboard removed. The patterns usually come out with the matchboard. They have to be placed back in the cavity before the top half of the mold can be made. Parting powder, I use ground soft coal, is used to keep the two halves of the mold from sticking together. The parting powder is cleaned off the patterns. A piece of wood forms the sprue, the hole through which the brass is poured. Facing sand is then placed on the patterns and the top half is rammed down the same as the bottom. Once this is complete, the sprue is removed and the mold taken apart. Now the patterns have to be removed. They are first loosened by tapping. These have to be lifted out carefully so they won't break the mold. Gates are cut with a knife. These allow the brass to flow from the sprue to the patterns. Holes are punched through the top half of the mold with a straw to allow air to escape ahead of the brass. After the holes are punched through, the mold is put back together and is ready for pouring. Pieces of iron are placed on top of the mold to keep the wooden part from burning. Once we have remelted a pot of brass a great deal, we always mix it up and throw in some fresh scrap. The difficulty in cooking the same brass over and over is that you boil the zinc out of it, leaving too much copper. The brass is ready to pour when it's boiling. When the tongs are laid on the top of the crucible, you can feel it churning. The blue smoke is zinc vapor. It only takes about a minute for the brass to harden. The sprue and gates are cut off and remelted. The butt plate mold is harder to make than the others because it has to be built up on each side. This makes it trickier to take apart without breaking. Sheet brass is first cast into a flat ingot. Then it's hammered on the anvil with the flatter. The hammering makes the piece much tougher and of denser quality throughout. The brass hardens from hammering, so it is heated red hot and quenched in water to anneal it, and then hammered and annealed several more times.
American rifles were usually stocked with curly maple. A gunsmith preferred to allow the plank to dry 2 years before he used it. Most craftsmen worked either wood or metal. A gunsmith had to be expert in both. The stock is more than just a piece of wood to carry the barrel and the lock. It had to be as carefully shaped and finished as a piece of sculpture. The character of its lines, proportions, and decoration distinguished the gunsmith, who was an artist, from one who merely managed to get it all to fit together somehow. The process began with bedding the barrel. The many other elements of the gun were proportioned and positioned in relation to it.
First, the center line is scribed on the stock. Then the breech plug is inlet at the back of the stock. This keeps the barrel from turning as it is being inlet. After the rough outline of the barrel has been scribed, the channel is roughed out with round gouges. Once the barrel channel is roughed out, it is then smoothed with an octagon-shaped plane. Since the barrel is tapered, the plane cannot be used to cut the channel to the final dimension. All the sides have to be fit by hand. The bottom of the barrel is sooted over the candle. When the barrel is squeezed in place, the soot leaves a dark mark on the high spots. These are then chiseled off and the barrel refit until it lays in tight. After the barrel is fit, the excess wood is sawed off the fore end. ramrod is carried on the bottom of the stock. A channel for it is cut with gouges in a plane, then smoothed down with a round file. "12 to 14 inches from the breech end, the ramrod enters the stock, so a hole has to be drilled for that length. When starting the bit, it's tied down with a piece of rawhide. If this is drilled properly, the wood left between the hole and the barrel will be 1/8 of an inch thick. Once the hole is complete, a test hole is drilled down from the back of the barrel channel to make sure the ramrod hole is exactly parallel to it. The butt plate is filed only on the fitting edges now. The outside of the butt plate is filed later. Fitting the butt plate governs all the shaping of the butt stock. In making the stock, the 3 important things are getting the barrel inlet, the ramrod channel drilled, and the butt plate fitted. You can't do any stock shaping until all of these things are fixed. Keeping the chisel very sharp is important while cutting hard maple on the end grain.
When the threads of a wood screw are filed by hand, each screw is going to be different. This means that when the butt plate is removed, as it is many times during the making of the gun, each screw must go back into the hole it came out of. Now that his 3 reference points, barrel, ramrod channel, and butt plate, are determined, the gunsmith can remove the bulk of the wood and establish the basic shape of the gun. He does not, however, finish it completely at this time. The final shaping is done in relation to the other parts that must still be added. The first part to be added is the lock. This must be set in a precise relationship to the barrel.
The lock has to be set before any of the fittings through the center part of the gun can be completed. The lock is inlet very carefully so that as much wood as possible is left for strength. Only enough wood is removed to allow the parts to work. The gun is weakest at this point, so any wood left makes the area stronger. The side plate, made of sheet brass, is mainly a washer for the 2 screws that hold the lock in place, but it's also a decorative piece. Designs on side plates vary from gun to gun, although generally they have a similar style. The side plate is inlet with lamp black, the same as the other parts. Afterward, it's filed off, smooth, and engraved. A round bottom chisel is used for cutting lobes and leaves. The majority of the engraving is done with the V-shaped engraver, which cuts a narrow line.
The lock fires when the sear is tripped. The sear is tripped by the trigger. So Mr. Gustler makes a trigger, and as he is making a finer than ordinary rifle, he makes a finer than ordinary trigger. The trigger is fitted into the stock in the right position relative to the lock and held in place with an iron pin.
The trigger plate protects the wood around the trigger. Since the recoil from firing the gun is taken by the wood around the tang screw goes through the stock and threads into the trigger plate to strengthen this section. Another screw goes from the back of the trigger plate to the thumb plate behind the tang to further strengthen this area. Once all these pieces are fitted, the woodwork here can be finished. Since this part of the rifle is heaviest looking, we take good care in shaping to give it as graceful an appearance as possible. A molding is cut along the forestock for the same reason.
The trigger guard, of course, protects the trigger and prevents the gun from being fired accidentally, but it does more than that. The long grip rail makes shooting the gun more comfortable by providing a place for the other fingers to rest. At the same time, the flowing lines make the gun more graceful in this critical area.
The front of the trigger guard is held in place with a pin, the rear with a wood screw. Only the extensions are filed before it's put on. After the trigger guard is inlet, the middle section is then filed. It's much easier to file once it's on the gun than when it's in the vise. The facets and molding on the trigger guard vary from gun to gun, although they all start from the same basic casting.
Once the fore end of the stock is finished, the gunsmith can attach the barrel. To do this, he first cuts 4 dovetails in the bottom flat of the barrel, and then from brass he folds up fittings called loops to fit into the dovetails.
Loops and pins are the most common method of holding in rifle barrels. Some gunsmiths like to use flat wedges instead of pins. Sometimes military weapons, especially French muskets, will have bands going all the way around the barrel and the stock. These are not as nice looking. After the loops are fit, they are inlet into the stock. A hole is drilled through the woodwork into the cavity where the loops fit. Then a hole is drilled through the brass loop. The barrel is put back in place and the hole continued on through the stock. A pin is then driven through this hole to hold the barrel and stock. 4 pins hold the barrel and stock together.
The Flintlock rifle was not invented in America. Though a distinctively American style did develop, it was for the most part an amalgam of English and German designs. However, one improvement that was purely American was the hinged metal lid of the brass box, or patch box, as it is called today. It was used to hold the patches, which are pieces of linen wrapped around the ball in loading to provide a gas seal and to seat the ball tightly in the barrel. The making of a brass box begins with the cover and finial, which are hinged together.
Fitting the hinge is the most irritating part of making the patch box. The hinge is curved to conform with the stock. This makes it hard to get the pin to go through. Once the pin is through, it's pretty hard to get the hinge to work because of the curve. After the hinge is made, the finial is filed out and inlet into the stock. The cavity is hollowed out by drilling a series of holes with a brace and bit. These are squared out with wood chisels. After hollowing out, the side plates are made. These have no function. They are strictly decorative. With all these inlet, the patch box is then filed to the contour of the stock. The engraving of the patch box varies as do all other engravings. I never make two the same. The spring that kicks the door open is placed under the finial. The spring that holds the door closed is set into the butt of the stock. The release is hidden as a screw in the toe of the stock. These releases are likely to be hidden anywhere. It's just a matter of style.
There must also be some way of holding the ramrod in the groove cut for it. This is done by attaching short pieces of brass tubing called thimbles. These are bent out of sheet brass. Everything on the gun is interrelated, not only in placement, but also in style. For example, the thimbles are filed into an octagon shape, which is an echo of the octagonal barrel above them. All the lines, moldings, and carvings are made to carry the eye smoothly down the length of the barrel. Mr. Gessler makes 3 thimbles to hold the ramrod. The fore end of the stock needs protection, just as the butt does. And to do this, he makes a piece called a muzzle cap from one piece of brass. After the curve is formed in the swage, the end is hammered into shape without leaving any wrinkles in the middle. A stud dovetailed onto the end of the barrel is threaded to hold the muzzle cap on. This rifle is more elegant than most guns of the colonial period. After the Revolution, embellishment became much more extensive. In either case, the style in carving wood, like that in engraving metal, was based on the use of C and S scrolls and shell, flower, and leaf patterns, though in carving the foliage tended to be more extensive and stylized than in engraving.
A molding is cut along the lower edge of the stock to make the butt more graceful. Cutting away the background smooth and flat is the most difficult part of relief carving. In designing carving, like engraving, I try never to repeat any design exactly. I like the carving to be different from gun to gun. This makes it more interesting for me. The carving and the molding slenderize and give the gun more grace, particularly around the lock and tang. This is the most critical part of the gun. You tend to look from here back or from here forward. You have to carry your lines through this area and try to keep it from looking bulky. You can do this by having your molding lines run lengthwise. Also, having your wood in more than one plane helps.
A 1776 ad in the Virginia Gazette runs, "Stolen from the subscriber on his march from Augusta to Williamsburg at New Kent Courthouse, a very neat rifle gun, the stock of sugar tree curled, made pretty dark by aquafortis." Aquafortis is another name for nitric acid. Various substances can be dissolved in it to make stains. In this case, Mr. Gustler has dissolved some of his iron filings. The application of heat turns the maple a deep reddish brown. Linseed oil is rubbed into the stock and the excess wiped off. After several applications of this, his finish has depth and translucency. You feel you can almost see into the wood.
The rear sight, made of iron, usually has a very fine notch. The front or foresight is made of silver with an iron base. Some are made of brass, some of horn or bone. A light material is used because it shows up bright in the woods, especially early in the morning or late in the afternoon.
Outside of military arms, guns were not made in standard calibers as we know them today. So for each rifle he made, the gunsmith had to make a matching bullet mold. Calibers in the 18th century were designated by the number of bullets that could be made from a pound of lead. Here he is casting bullets to use in testing the gun and in adjusting the sights. To load a rifle, a measured charge of powder is poured down the barrel. The patch is lubricated with tallow or moistened in the mouth and laid across the muzzle. The ball is placed on top of it and rammed down on the powder charge. The priming charge is put into the pan and the steel dropped into position. We have seen a remarkable craftsman do a remarkable thing. He started with some crude bars of iron, a plank, and a basket of scrap brass. He has worked with these materials for over 300 hours, with tools he himself made and with the combined skills of the blacksmith, machinist, foundryman, woodworker, and engraver. Mr. Gustler has shown us what it means to be a master of his craft. He has created a flintlock rifle like those that helped establish our independence and enabled free men to feed and protect their families in the wilderness. But there is more. This rifle is the work of a thoughtful and sensitive man who has brought many elements into a harmonious balance so that every part flows together with grace and style. For, like many gunsmiths before him, Wallace Gusler also believes a rifle can be a thing of beauty.